Rain is never just composed of water. Chemicals and particles in the atmosphere can be found in every drop. Some compounds, like carbon dioxide, may even regularly fall slightly acidic. On the pH scale, which measures acidity, each whole number is 10 times more acidic than the one above it. Where normal rain has a pH of roughly 5.4, rain that in these cases can range as low as 3.7. Oxides of nitrogen and sulfur dioxide may appear naturally as a short-lived byproduct of volcanic eruptions or lightning strike. But power plants, refineries, and vehicles that use fossil fuels consistently pump large quantities into the air. These dangerous gases travel with the wind, spreading hundreds of kilometers from the pollution source. Acting like a roaming cloud of destruction, their presence dramatically increases the acidity of local precipitation, creating acid rain, acid snow, and acid fog. Zooming into the effects on aquatic ecosystem, acid rain can significantly impact aquatic plants. Changes in water pH affect nutrient availability and can lead to the mobilization of toxic metals, influencing the health and growth of aquatic plants. Today, we aim to uncover the effects of acid rain on aquatic plants such as Melodia species. Will this delicate ecosystem withstand the silent intrusion?
These are materials and apparatus we have been using for our experiment. 900 ml of distilled water was measured and poured into each container. 2.5 ml of vinegar was transferred into experiment 1 container and 2.5 ml of lemon juice into another container. The initial pH of each solution was measured using a pH meter and recorded. The Elodea plants were placed into each container. The initial temperature of each solution was measured and recorded. The experiment was set up as shown in the picture. The Elodea plants was left for 24 hours. After 1 day observation period, the Elodea plants had shown some changes in their color leaf. As we can see, the vibrant green color of Elodea has remained the same as compared to the experiment 2 container, which turns green yellowish. Meanwhile, the Elodea in experiment 2 container showed significant changes in their color, which turned brownish. Lastly, the final temperature in each solution was measured and observed. This table shows the result of the experiment. The hypothesis is based on the expectation that the combined stress of high temperature and acidity in experiment 1 will exacerbate the negative effects on plant health compared to the experiment 2. Acidic conditions alone are known to impact plant growth, and the addition of high temperature stress is hypothesized to result in a compound, more severe stress response. Overall, acid rain is harmful to plants, and when combined with factors like rising temperatures, the impact on plants becomes more severe. The chemical reactions causing acid rain are affected by temperature, and as the earth warms due to global warming, these reactions speed up. This acceleration leads to more frequent and intense occurrence of acid rain. One of the effective ways we can all contribute to mitigating the impact of acid rain on our environment is by reducing energy consumption. Use energy-efficient appliances and turn off lights when not needed. By reducing energy consumption, we help decrease the demand for electricity generated from fossil fuels. Besides, limit vehicle emissions by choosing environmental-friendly transportation options, such as walking, cycling, or using public transportation. This will help in reducing emissions that contribute to acid rain. Lastly, practice the 3 R's to minimize waste generation.